Hello everyone, my name is Jason Chung, and for this video I'll be talking about the Naniar package. So I don't know for most people, but I feel like one of the biggest obstacles I face when doing data analysis is what to do if there are missing values. For instance, how many missing values are there? Are there any patterns to these missing data? Should we interpolate these missing data as it may contain useful information or just delete them? So with the Naniar package, it can help us solve these questions as it is a library package meant to visualize these missing data. However, there are some limitations with the functions, which I'll be talking about and briefly showing and discuss. So in this section, this is how you will load the Naniar library. So starting with how many missing values there are, I'll be using an example data set that Professor Joyce Robbins used in class, which contains self-generated missing data, as you can see. So typically, some common ways to quickly find missing data are to use summary, the call sum, or the row sum methods. Although they do the job, there are things I don't like about each of them. For summary, it could be hard to read if there are a lot of columns. And for call sum and row sum, you cannot order the amount of missing data unless you turn it into a data frame. So by utilizing functions like the misvar summary for missing data in columns or miscase summary for missing data in rows from the Naniar package, not only is it more readable, but it keeps it as a data frame, orders the amount missing and decreasing order, and tells you the percentage missing as well. Not only that, but you can still use functions from the dplyr package to manipulate the data frame, as you can see, which when I use the filter function. However, there is a small downside though with these, uh, which is that you cannot display missing rows and columns as it's mainly meant for quick visualization. So you will have to use the base uh, R functions to do so. Other than that, I still think it's pretty nice. The next thing I like about Naniar is that it can help us see patterns in missing data by using the this_miss function, which will generate a heat map on its own rather than you creating one yourself. Additionally, you can order the cluster in a hierarchy order to help better see the patterns and can still perform faceting as well. However, the small downside when performing faceting is that you will lose a percentage missing in each column. As you can see, before faceting, you can see that there are missing percentages in each column, but after faceting, it's all gone. Unfortunately, this is an expected result according to the documentation. So I thought I could try getting the percentage of each of them and manually adding it to the graph itself. However, although I was able to get them manually, I was kind of unsure how to add it to the graph. Another quick thing is that you can also graph the missing data of each column and rows to help see if there are even more patterns using the ggmisvar and ggmiscase, as you can see. Other than that, lastly, what stands out for Naniar is the geom_misspoint function. Typically, when we use geom_point from ggplot, it does not include missing data, as you can see from the warning message. However, for the geom_misspoint, it will show the missing values by interpolating them with 10% of the minimum value while also allowing faceting to be performed. A downside of the geom_misspoint is that there's no way to change how it interpolates the missing values, unfortunately, as it's always set to be 10%. So a workaround can be doing it yourself by using the base R input methods like the following code, but it kind of defeats the purpose of the geom_misspoint function, so that's up to you. All in all, there are some other functions in the Nania package that are quite useful that I have not discussed yet, but these are the functions that stood out to me to answer our following questions above. Other than that, thank you so much for watching this video.